So hi everyone, I'm Li Chen. I'm here to help Mingxu Zhou for presenting the paper StyleFactory towards better style alignment in image creation through style strength-based control and evaluation. So first, let's take a look at the following case. In text-to-image generation, users often use prompts or reference image to describe a certain style, hoping the generated results will reflect their preference on certain aesthetic features. These personal image styles we call are generally made up of visual elements like color, composition, texture, and lighting, and they tend to be unique, abstract, and nuanced. For ordinary users, a common creative way is to use these personal styles to render specific subjects or something existing images so that they can quickly build a personal image gallery with similar visual styles, just like a real artist. However, this process is always tough for the novel users. On one hand, they might find it difficult to tell the model what kind of style they are looking for. On the other hand, due to the model's black box nature, it's also hard to know whether the model truly understands their intents. Therefore, our work looks into how can we better help users achieve style alignment with the model. Before designing the solutions, we conducted a formative study to explore the challenges and opportunities in this style-aligned image creation. Specifically, we recruit 8 ordinary image creators, gave them a creation task, and observed their workflow. Participants were asked to use Midjourney and generate images that could well demonstrate their personal styles within 2 given subjects. We summarized 4 main findings from the study. Through the task, we noticed that participants typically follow a cost-to-find input iterative pattern. Besides, they were eager to reuse the existing old styles into the new context, but they were challenged in style management and the application. In addition, the lack of accurate style control and the evaluation support were the main obstacle they faced in achieving the style alignment. So notably, participants show a clear subjective perception of style strengths. That is, they were able to identify the strength difference among images within the same style and even imagine how this style would appear at weaker or the stronger strengths. So for example, this one was selected as a reference, but actually they want to control the density of these geometric elements to be higher or lower. And this white wall texture is another example. They don't like such big wrinkles. Perhaps those smoother ones are more suitable. Yeah, so how about making a bold decision to design the control and evaluation interactions just based on the concept of style strengths? We integrate these findings and establish our design goals to enhance the creation experience. To validate our idea, we present the system StyleFactory. This is how the system looks like, and now let's see how it works. Here is a pre-recorded video.
Our user interface consists of 4 views. In the coarse machining view, we can type text and upload reference images to describe the desired styles. Other parameters like
Please help me turn up the video.
Generation number are also available. Based on the input, the system will generate a batch of images and display them on the canvas. We can open a preview window to enlarge the image and see its caption. Move to the fine machining view. We specifically introduced a style strength axis. For example, here, we want to specify a certain personal style, described as a feeling of block-shaped effect on brushstroke. To achieve this, the first thing we need to do is to identify the strength of these images in the desired style. After that, we can drag some of the images into the below axis and rank them in sequence according to their strength values. Like this. It indicates that there is a strength variation relationship between these three images. Next, the model will be trained based on this image sequence and reorder the remaining images on the canvas to showcase their style strength distribution along the user-defined axis. This allows us to evaluate the current alignment gap with the model. Then, we can easily locate those images that are obviously out of place and drag them into the right position along the axis for correction. In response, the model will be trained again and reorder the images to show its new interpretation of this style. By repeating the above steps, we can finally achieve style alignment with the model in a cyclic interaction. In addition, we provide a test list at the top of the canvas, which allows us to upload an image and see the effects of the current captured style in different strengths, ranging from weak to strong. If these results are already quite satisfactory, we can save the whole canvas and access to the style library. There is a card list for unified management of those user-defined personal styles. Now, let's go back to the style we just saved. In the personalized generation view, we provide two generation modes of style rendering. In Prompt plus Style mode, we can select a specific style strength value and enter prompts to describe a certain subject. The images generated will be shown in the gallery below. As we can see, the scene of sunrise by the seaside is rendered with a kind of colorful block-shaped effect, which is consistent with the selected strength. As for the Image plus Style mode, we need to upload a local image. This time, as a contrast, we select a weaker strength value to explore different outcomes. As expected, the original image is imbued with a feeling of soft and spread out effect on brushstroke.
Yeah, so that is the main interaction process of our system, StyleFactory. Now I will give you a quick overview of our technical details. In our system, the user-side input includes a sequence of images along with their associated style strength values. Specifically, we propose a training engine to build a bidirectional mapping between the image features and the style strengths. Next, we modify a diffusion-based framework and integrated the style features to generate the final images. Also, we conducted a subjective experiment to evaluate the engine. We use this StyleFactory and Midjourney to generate pairs of images. Then, based on this dataset, we invited participants to give ratings on the style consistency between the generated image and the reference image. The result demonstrates that, in most cases, our engine can effectively deal with the different style types and accurately generate in the given styles. We also conduct a user study to see the overall performance of the StyleFactory compared to the Midjourney. We mainly focus on two evaluation goals. First, the usability of the system and whether it facilitates the style alignment. Second, the creativity support and the user experience in human-AI interaction. The study involves an open-ended creation task and the post-task questionnaires and interviews. In general, participants highly appreciate our control and evaluation. The style strength axis was considered accurate in expression, easy to define, and comprehensible to the model. Here we showcase a specific iteration process of one participant. On average, they spend 5 times to image recording to achieve the final alignment. In terms of creative support, StyleFactory performs better in exploration, expressiveness, and immersion. As the figure shows, participant 22 can freely create pixel art styles with varying levels of resolution, while participant 12, interestingly, he was hooked and exploring what the model could generate beyond the strength range of the example he provided, just like the bright sunlight effect here. So as for the human-eye interaction, they consider our system as appearing more collaborative and transparent. Specifically, one participant said that just drag and drop operations are made more engaging than the fixed conventional interaction in other tools. Of course, this result did not mean that StyleFactory is always good, but they do show that for AI-powered image creation tasks, there is still plenty room to explore the human model interaction. Finally, we briefly propose one of the discussion points in our paper. That is how to use the image sequence in the axis. You know now all styles can be extended with clear variations in strength. Participants argue that the style strength axis can also be used to express other subjective concepts. They can create a preference ranging from dislike to the like, as well as gradual change from the abstract art to the vector art, or even a sequence devoid of any logical order. Furthermore, the elements of the sequence can go beyond the images and encompass other models such as the task, audios, and the videos, as long as they processes continuous dimensions in some form. We think a promising research is to characterize this sequential definition for new attributes and specify this applicable group. Yeah, that's conclusion. Thank you for listening.
Thank you. We have time for one short question.
Hi, good morning. Thank you for your interesting presentation. Actually, as we all know, the generative AI is burgeoning on in HCI domain, and there are various generative AI projects. So I'm really appreciate your focused point, and maybe it's one kind of the detailed observation is the style strings. So I really want to know, do you think the user perception of the style strings could be applied in any other domain, maybe some specific, other specific design or some customization scenarios? Thank you.
Yeah, thank you for your question. Actually, I haven't thought about this problem before. That being said, I believe in our work, the style strengths essentially serve as a common language to bridge the communication gap between humans and the models. For example, the dislike to like, or just I mentioned before, the abstract art to the vector art. So I think maybe we can look into some mediums that haven't been used or discovered yet, figuring out maybe which ones are within human expressive capabilities and which are computable for the model, and maybe seek other intersections among them, or maybe other interaction just beyond the slides. Yeah. Thank you.
Okay, thank you. Thank you for your answer. Thank you.
Okay, so let's thank our speaker again.